Hi. First, I want to thank organizers, staff members, sponsors, participants, volunteers, and also I want to thank Sorcy team for helping me to improve this presentation. My name is Dmitry. I am a senior software engineer at Sorcy, based in Melbourne. Over the last 8 years, I have primarily worked with Ruby as my main primary language. I worked in companies of all sizes, from small startups and to medium and large enterprises across various domains. Now I work at Sorcy, which is owned by SIG. Thanks them for my sponsorship. If you want learn more about my work or other pet projects, please follow links, GitHub and LinkedIn. In this presentation, I will show the 5 project life stages. I will use an example of an online store with buyers and sellers, because this pattern can be found in many other companies. We will start with one developer in the company who develops Rails monolith in bootstrap stage, then startup stage, small company, medium company, and finish with a big company with multiple domains and teams. The presentation includes insights from my experience working in companies of different sizes, but your experience can be different. Some information may be apparent for experts, but it can be interesting for engineers in small companies looking to improve their project, and for engineers in large corporations seeking to understand the growth stage they might not have part of. The presentation contains information about scaling of code, team, databases, and services. We will also discuss a little bit of DevOps and front-end. In the beginning, we have the Rails new command, and now you're the owner of a company. Yeah, the first stage of the project is Bootstrap. This stage is of project focused on code scaling. One developer is responsible for front-end and back-end. Their primary goal is to deliver features that will generate revenue and enable of hiring of another developer. At this stage, writing readable and maintainable code is crucial for future scalability. The first developer sets the code foundation, which is difficult to change in the future. Be cautious. A future developer at the company may have known your address and could be dangerous if you write bad code. Instead of over-engineering, like asynchronous architecture with Kafka and microservices, think about how to ship code. Do not scale the project before you really need it. And the first recommendation at this stage is add testing. Yeah, sorry for obvious things, but add RSpec. It is the best Ruby testing framework. You can quickly write VDD scenarios for tests. In this example, has a simple testing concept. We have a sign-up logic and 2 contexts. There is a failure path with invalid email and success path with valid email. Success path includes also 2 additional paths. With existing user, in this case, we shouldn't create a new user. And when user doesn't exist, we must create a user. You can use this success and failure testing almost with any logic. It's easy to read and maintain. The test coverage is like a quality rating of your project. If you don't have time to write good tests, write at least smoke tests. With good tests, it's easier to refactor the code and scale it in the future. To improve the project, make sure you add relinting. Add Rubacop. You can use default code styles or create your own rules, but do not get too fancy with it. Having a consistent code styles help to improve productivity, as it allows to easier code review for developers in the same who write and reads in the same style. Using namespaces in your code and database is a good practice. When a new developer looks to the app folder, they must have a common sense about what the app is about. Additionally, using namespaces will help you to split application into domains in the future. In this example, we have two namespaces, business and individual. Service objects. Encapsulate the business logic in service objects for easier code maintenance and refactoring that fat models and controllers. Usually classes in object-oriented programming are nouns, but with service object, it can be verbs. You can write actions in any action in a class. Also, a good class is a small class, and make sure to namespace it to prevent a mess. In this example, when a user buys an item, they create an order, which triggers updates of statistics and send notification to the user. But in other scenarios, when we must create an order, for example, when admin creates an order for the user, there is no need to notify the user, but we must set admin ID. Or imagine any other scenarios. Avoid writing all the logic in one model or controller. If you have multiple scenarios, better to create an order in service objects. Add Docker Compose to package all requirements. It will save you time when you boot the project. Continuous integration, make it simple like GitHub Actions. It will save you hours to ship the code. Add error tracking and monitoring. You should be able to identify bugs easily using user-friendly tools like Datadog and Honeybadger. Encryption is important to protect users' personal information. It is difficult to predict how data breaches can occur, but it happens frequently. Attackers often require users' email to send them spam and earn money, and having access to their full name makes it even easier for them. In this example, I demonstrate how to use simple Rails encryption for emails. However, at Storsy, we utilize more advanced tools and techniques and regularly rotate our keys to ensure maximum data protection. Do not encrypt everything, otherwise your database is slow and useless. Use hashing to improve search, but have it secure. Regardless of quality of the code, the number of developers you employ, or the architecture you are using, failure to protect your data can quickly lead to business failure. Some of the useful tools I recommend for this stage of the application is active interactions, Trailblazer, especially operations, and almost all gems from DryRB. For books, I recommend effective testing with RSpec 3. And the next stage of the project is startup. This stage of the project focuses on scaling of people in your team, and do not, do not confuse this stage with startup companies, because some startups can have hundreds of developers. The development departure has more than one developer. We have a team of 5 developers. The first developer who has delegated tasks to others, reducing the risk of single point of failure and allowing scalability through teamwork. The lead developer is responsible for 80–90% of coding work and 10% of management duties at this stage. Other developers on the team should be full-stack developers to ensure they can be replaced if necessary due to unforeseen circumstances like illness. The first recommendation for this stage is to introduce good playbooks to run projects or perform manual tasks such password rotation, database updates, and other tasks specific to a company. Avoid being the only person who knows how to do things. Instead of share the information with others through documentation. Otherwise, people will ask you each time when they need to perform a task. And it can be problematic when you are on vacation. Playbooks should live with the code and must be developer-centric. Add pull request templates to all repositories on your GitHub, on GitLab. This will make it easier to code reviews and save time for everyone involved by providing valuable information such as links to documentation, links to tasks, screenshots, or list of changes. Staging is needed for code testing, and it must be identical to the production most of the time. All developers, especially newcomers, have valuable ideas how to improve the project. However, they may not generate a good idea when you ask them on the spot. Having a design place, such as documentation, Slack channel, Kanban board, is essential to know these ideas and discuss them regularly, at least once a month. Even seemingly silly ideas should be collected, as they may lead to genius solutions how to improve the project. Pairing can help developers share knowledge, increase productivity, and learn from each other. It involves observing the app people use, frequently used ID hotkeys, and debugging techniques. This is valuable for newcomers first. On-call schedule help to reduce developer distraction. Developers rotate between regular feature tasks and resolving errors and support requests each week. PagerDuty is a good tool when we use at 30 for on-call shifts. Pay attention to project incidents and track them to prevent future mistakes and avoid unnecessary costs. I recommend a book, Extreme Ownership, for this stage of the project. And third stage is small company stage. This stage is of the project focus on scaling of teams. And you work with multiple teams. You must organize for them a better environment and code isolation. You will have 2 or 4 teams or 6 to 15 developers. At our store, we have a tech lead who manages 2 teams. Team 1 is responsible for developing a mobile application for individuals or buyers. And Team 2 is responsible for development a dashboard for sellers and aim to improve their business experience. Both teams have their leads and developers. Have a good onboarding process or playbooks with a checklist for new team members to complete it before coding. Include information on getting a laptop, setting up accounts, learning about database models, code conventions, and company culture. Also have a well-defined offboarding process with a checklist to revoke access and return company property. Revoking access is crucial to avoid security risks. To isolate code and split responsibility in monolith, use code owners on GitHub or GitLab. Someone who changed code under a specific namespace must pass a code review from a different team. This helps to maintain different code styles and project planning. It also prevents bugs caused by someone from another team from changing the logic of the code without proper review. Each team needs staging to test features without mixing them with changes of other teams. Multiple staging can cost lots of money, but save time of waiting and testing and releases. Feature toggles should be used to avoid issues with huge new features that cannot be easily reverted from Git. Also, it is avoid downtime for releasing a feature because it can be applied simultaneously to front-end and back-end. This simple technique enables you to redesign entire project and continuously merge incomplete features to the main branch. However, it is essential to cover both enabled and disabled scenarios in your tests. And when the feature is released, remove the feature toggle by assigning a specific responsible team. maintenance mode. During a database migration, it is essential to prevent users from sending requests to your servers. Instead of showing them 500 error, a friendly message asking them to return to the website in a few minutes can improve user experience. It is okay to have downtime sometimes. It is way less effort than zero downtime. You can deprecate all API endpoints for mobile apps, or if you want to remove errors from old app versions spamming your error tracking system to avoid destruction, you can ask users to download a new version. Soft updates prompt users to update, but don't prompt them to update, but don't force them, while hard updates require immediate actions. Hard updates are necessary for situations like app hacking or crucial vulnerabilities. I recommend books like Peopleware and Staff Engineer Path for this stage of application. And fourth stage is medium company. This project stage focuses on scaling domains, and it is good for dividing our infrastructure. We have 2-3 domains, 5-12 teams, 16-50 developers. We have too many teams and people to manage by one tech lead, and we must add additional level of management to manage each domain or tribe. Tribe is like a separate isolated company inside the company. In this example, we have a tech director who manages 2 tribes, individual experience domain and business experience domain. Each domain is managed by a tech lead or domain lead, and who manage team leads who manage developers. Each team in each domain work independently in their field. For example, a mobile application team in the individual experience domain and business API team within business experience domain. At this stage, you could move to a cloud provider like AWS or Azure or Google Cloud, and the first recommendation to start to manage your core infrastructure in more scalable way. It is the best to have your project architecture written, documented in the code. Add Terraform if you have more than one service and many databases. It is simple, but alternatives like Pulumi exist if you want to write infrastructure in the same language you write application. If you have millions of users, you cannot serve them with one application. You will need to make copies and split the load. During the day, you can have different peak hours, like when people use your application. With auto-scaling rules, you can set up different scenarios for scaling. For example, there are fewer users at night, so you can scale instances down to 1. And in the middle of the day, you may need to scale up to 3 or up to 10 instances of your application during the sale of in your store. One of the well-known technology now is Kubernetes. All cloud providers like AWS, Azure support it. However, consider using it without tying to a specific cloud provider. It will help you change providers when they change prices. But without proper knowledge, Kubernetes can be a nightmare. Consider using some alternative like AWS Fargate, Azure Container Apps, which supports orchestration and auto-scaling. It's easier for non-DevOps people, and do not manage by yourself what you can delegate to a cloud provider. When your monolith is too big, you will consider adding new services. Avoid making them dependent on each other with synchronous communication like HTTP requests. Chain service calls can be broken. With event-driven architecture, services should be independent on responses of each other. Here are some examples of message brokers to use in your code, in your project. We can talk about technology, why one technology is better than another, but better to try them. yeah, if you like Kafka, because it's written in Java or Scala, or you can use Rabbit, it is written in Erlang, and use Event Bridge if you are locked to AWS. Database scaling. Before real scaling of database, find the problem with indexes. Try to reduce slow queries by adding proper indexes to specific fields in your tables. Vertical scaling of your database has limits. To reduce the load to your main database, add read replicas. Each read replica is a full copy of the main database. The downside, it will cost twice as much to have 2 replicas. Database splitting is necessary to separate the data of one domain from another. Usually, it's splitting together with code of your monolith. If you split high-loaded parts of the application, you can scale it more affordable than the whole application. To do splitting correctly, the data must be isolated under specific namespace. Table with different namespaces shouldn't have direct access to each other. However, sometimes code from different domains requires information from another domain. In such cases, reference tables or projections can be added. These tables contain duplicated data, but have limited fields. They can only be updated via synchronization events initiated by a regional domain, which serve as a callback when the original data is updated. In this example, the left image shows the database without reference tables, where domains directly access each other, tables of each other. The right image shows the database with reference tables. You can start adding reference tables within one database, and after data is completely isolated within one database, you can split it into 2. Consider using non-relational databases as an addition to your relational database. They are much cheaper, do not need to full copy for replication, and scale horizontally very well. If you have a table with 1 million of analytical data, rows of analytical data, you can save thousands of dollars by adding NoSQL and moving data to this database. Here are some examples of non-relational databases. Elasticsearch will help to improve full-text search. Neo4j helps you to build graphs if you are building a social network or anti-fraud system. DynamoDB is needed to store terabytes of data at an affordable price. And Redis is simple key-value storage, is used for caching, and as a vector database for your generative AI startup. Remember to prepare for scaling by emulating a high load to your system, and do not ignore security audits to be ready for hacking attacks. Startups and small companies can be stressful for beginners. If your company has good processes, consider hiring and training junior developers. They are highly engaged people. They can grow alongside the project and become knowledgeable about every aspect of the application. Senior developers can share their knowledge with them, and everyone can grow together. You can find quality junior developers here at RubyConf. Tools. I recommend using Strong Migration Gem. It is like Rubacop for your migrations. Use it to prevent locks and downtimes if you have millions of rows in database. Also recommend PackWalk. This gem will help to isolate code in your monolith before you split it. In Source, we use manual Rubacop tasks, but this tool is more advanced. And I recommend books for this stage is Learning Domain-Driven Design, Design Data-Intensive Applications, and monolith to microservices. And I also like O'Reilly books. A fifth stage of the application is big company. And this is it. You made it. You have built a big company. Now you don't need tips from a guy from RubyConf. Using the same pattern, you can scale infinitely by adding vertical management and scaling horizontally with teams and tribes. Conclusion. Divide et impera, which means divide and rule, is the main principle of scaling. Without it, you have limits. There are many things to discuss about scaling. The presentation discussed some of them. The most important advice is to wait to scale before you really need it. Premature optimization can kill the business, but investing in people is better than adding new modern technology and letting developers to burn out. If you have questions or feedback, please write to me. This presentation can be found by this QR code and the link. Thank you.